Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 17 video on the chapter of probability, where I will be discussing about another supporting concept number 3 as how to find the number of prime numbers between any two given numbers. Now the method I will use will be a little manual, but when the range of the given numbers, that is in this thumbnail you can see how many prime numbers are there between 51 and 100. So the range is not is around 50. It is not too large. So for this kind of range, it will not take that much time to find the number of prime numbers. So this video is part of the playlist CBSE Maths for class 9, following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel and do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 17 video, where I will be discussing how to find the number of prime numbers between any two given natural numbers. Okay, so how many prime numbers are there between two positive integers, that is natural numbers m and n, where obviously n is greater than m. Okay, now the fundamental concept that will be used to find the number of prime numbers is that every prime number greater than 3 can be expressed in the form 6n plus 1 or 6n minus 1 for some natural number n. If you take any prime number, that prime number is either in the form 6n plus 1 or 6n minus 1 for some natural number n. As an example, you can see the prime number 5 is 6 into 1 minus 1. So n here is 1. Similarly, 7, the prime number 7 can be expressed as 6 into 1 plus 1. So the n is 1. The prime number 11 can be expressed as 6 into 2 minus 1. So n is 2. Similarly, 13, 6 into 2 plus 1, n is 2. 17, 6 into 3 minus 1, n is 3. And 19, also 6 into 3 plus 1, n is 3. Okay, so this is the main concept based on which I have written down a little a method using which you can find how many prime numbers are there between any two natural numbers m and n. Okay, the step 1 is we have to find the least positive integer, that is we have to find the least natural number p such that 6p minus 1 is greater than equal to m, or 6p plus 1 is greater than equal to m. M is the so remember that we are trying to find the number of prime numbers between m and n. So the range is m to n, where obviously n is greater than m. So first we will find the integer p such that 6p minus 1 is greater than equal to the least p, such that 6p minus 1 is greater than equal to m, or 6p plus 1 is greater than equal to m, whichever is applicable. Step 2 is we have to find the largest natural number or positive integer q such that 6q minus 1 is less than equal to n, or 6q plus 1 is less than equal to n. Once we have found p and q, then what we will do is we will from p to q. So p and q are some natural numbers. We will start from p. Starting from p, we will check whether 6p minus 1 or 6p plus 1 is a prime number or not, and then we will keep track of the count, and then we will move on to p plus 1, and we will see whether for p plus 1, that is 6 into p plus 1 minus 1 is a prime number or not, or 6 into p plus 1 is a prime number or not. So starting from p up to q, we will check. So step 3 is count all prime numbers of the form 6n minus 1 or 6n plus 1, where n, the natural number n, we will vary from p to q. Okay, let's see in some example how to apply this concept. So find all prime numbers between 10 and 50. So first I need to find P and Q. So what is P? P is the find the least P such that 6P minus 1 is greater than equal to 10 or 6P plus 1 is greater than equal to 10. The way you do is, you can find P is that you simply divide 10 by 6. If you divide 10 by 6, it will be something. So if you divide 6 by 10, it will be 6. Okay. P has 6. Okay. So you can do manually. I can see that 6 multiplied by 2 minus 1 is 11, and 11 is greater than equal to 10, and and n is 2. So 2 will be the least natural number. 2 will be the least natural number because 6 into 1, if you consider n to be 1, 6 minus 1 is 5 and 6 plus 1 is 7. Both are less than 10. So if you consider now 2, then 6 multiplied by 2 minus 1 is 11, but 6 multiplied by 2 plus 1 is equal to 13, is equal to 13. So so the P will be 2. The least, the P has to be least such that 6 into P minus 1 is equal to is greater than equal to 10. In this case, 6 into 2. So P is 2. P is 2. We can see that 6 into 2 minus 1 is 11, which is greater than 10, and also 6 into 2 plus 1 is 13, which is also greater than 10, and P is the least. So P is 2. So for small numbers, I mean these M and N will be relatively small numbers. Maximum they could be 3-digit numbers. So you can mentally or orally find out what will be the values of P and Q. Okay, so step 2, we have to find Q such that 6Q minus 1 or 6Q plus 1 is less than equal to 50. 50. Okay, so I can see that 6 into 9 is 54. Minus 1 is equal to 53, which is greater than equal to 50. Which is greater than equal to 50. I have to find the largest. So this is Q. Q is 9. Q is 9. And this and you cannot Q cannot be 10, because 6 into 10 minus 1 is 59, which is greater than 50, and also 6 into 10 plus 1 is 61, which is also greater than 50. So clearly Q equals to 9 is the largest natural number such that 6Q minus 1 or 6Q plus 1 is less than equal to 50. So we have found P equals to 2 and Q equals to 9. Now what we will do is we will keep on checking whether starting from P, you can consider making a table like this. N will we will vary from starting from P to Q, that is 9, 2, 3, 4, 5, 6, 7, 8 and 9, and then we will also find the value of 6n minus 1 and 6n plus 1. Okay, so this is 11, this is 13, and this is 17, and this is 19, 24, 23, and this is 25, 30, 29, 31, for 6 it is 36, 35, 37, 41 and then 43. For 8 it will be 48, 47 and 49, and for 9 it will be 54, 53 and 55. Now, so I have found all the values of 6n minus 1 and 6n plus 1 where n is varying from p to q. P was 2, this was p, and 9 was q. Now, of all the numbers 6n minus 1 and 6n plus 1, I will see how many are prime numbers. So this is prime, 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 prime. So how many prime numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 prime numbers between 10 and 50. Now I could be doing some silly mistakes and coming up and could come up with wrong answers. If that happens, then please feel free to let me know in the comment section. I will appreciate that. Okay, so there are, I hope I did not make any mistake. So there are 12 prime numbers between 10 and 50. Let's see another example. Find all prime numbers between 51 and 100. So first we have to find the least p such that either 6p minus 1 or 6p plus 1 is greater than or equal to 51. You can do it orally. We know 6 into 9 minus 1 is 53. 53. So this is obviously, no, this will not have, okay, so this is greater than 51, and the 9, so p is 9, p will be the 9, value of 9 will be the least value of p such that 6 into p minus 1 or 6 into p plus 1 is greater than or equal to 51 is 9. Because if you take 10, obviously 6 into 10 minus 1 is 59, which is 10 will obviously work. We are considering the least. You can, for verification, you can check. If you check for 8, 6 into 8 minus 1 is 47, which is less than 51. Also 6 into 8 plus 1 is 49. This is also less than 51. We have to consider the least p such that 6p minus 1 or 6p plus 1 is greater than or equal to 51. So obviously p is equal to 9. Okay. Now what about q? We have to find the greatest q such that 6q minus 1 or 6q plus 1 is less than or equal to 100. So I know 6 multiplied by 16 is 96. Minus 1 is 95. Is 95. Okay, and 6 multiplied by 16 plus 1 is 90 is 97. So so can we say that q will be 16? Is q the largest natural number such that 6q minus 1 or 6q plus 1 is less than or equal to 100? If you consider 17, 6 into 17 plus 1 is definitely exceeding 100. This is 100 and this is 103, which is greater than 100. Also 6 multiplied by 17 minus 1 is 101. This is also exceeding 100. So definitely the largest q such that 6q minus 1 or 6q plus 1 is less than or equal to 100 will be 16. So we have found p and q, and then we will quickly we will varying from 6 to 9 to 16, 9, 10, 11, 12, 13, 14, 15, 16. We will quickly find the value of 6n minus 1 and 6n plus 1, and of these numbers we will see how many prime numbers are there. Okay, so this is 53 and this is 55. This is 59 and this is 61, 11, 66, 65, 67, 12, 72, 71, 73, 13, 78, 77, 79. For 14 it will be 84, 83 and 85. For 15 it will be 90, 89, 91, and for 16 it will be 96, 95 and 97. So let's circle all the numbers which are prime. 53 is prime, 59 is prime, 61 is prime, 67 is prime, 71 is prime, 73 is prime, 79 is prime, 83 is prime, 89 is prime, 97 is prime. So how many prime numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 prime numbers between 51 and 100. Seven, 21, 3, no. 55 is not prime, 91 is not prime, 95 is not prime, 77 is not prime. Yeah, I think this is so there are 10 prime numbers. Okay, so I hope you understood how we can, using this method, we can find how many prime numbers are there between any two given natural numbers m and n, where n is greater than m. So some problems on probability are based on this concept. We have to find how many prime numbers are, to solve the problem, to solve some specific problem of probability. You have to find how many prime numbers are there between two given natural numbers. So I hope this video will be beneficial. Based on this concept, I will solve I will solve some problems on the probability in the next video. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Now if you have any better way or faster way of as how to find the number of how many prime numbers are there between any two given integers, then I will appreciate if you please share that concept or formula in the comment section. So I'm ending the video here. Thanks for watching, and until the next video, take care and bye.